Okay, hello again. So let's continue our work with solving an example for tension test here. Uh, I chose the data that we had in our lab session. So they are the dimensions of our specimens here that we have T1, T2, T3, and then we have W1, W2, and W3 here. Okay. So let's say that we want to have the average number of these thicknesses here. I'll use one of the built-in functions in Excel, so average, which is here, and then I'll select these three. It will give me the average. Okay, and then for the average of width, I'll say I'll use the same function. Again, these three will give me the average of these three, and then for calculating the area here, I need to have what? I need to have the average thickness multiplied by average width. So I'll use this formula. Okay, I'll choose this one and then multiply that one with the average width. Okay, and it'll give me the area. This is the average area of the specimen that we use for the steel. Okay, and so right now I want to make the stress from what? From the load. Okay, let's say that I have the main, let's say raw data. Okay, so I'll first copy the strain here. Okay, and then I need to make actually the stress. Okay, so let's say our stress, and it is the units would be in MPa, megapascal. I think that you guys know it. Why? Because we this here is millimeter square. Okay, so it's 10 uh, uh, power minus 6. Okay, so when we have stress is actually equals to force F over cross-section area of the specimen. Yeah, so we need to make some formula like this. So I'll say this equals to the load, which is was in Newton. Okay, equals divided by 18.778788. Okay, so this is the first specimen. This is the first stress. Okay, and then we need to go all the way down to do this, to do this division actually. So what we can do is that we can hold the shift arrow and then control down arrow. Well, it go a lot. Okay, so let's say how many data we have here. So 6123, the row is here. Okay, so let's say I want to go from here to uh, Q6123. Then I'll hold the shift, I'll click enter. So I've selected all the empty cells here. Then I'll go to field series, autofill. It will do the job for me. Okay, it will do the job for me. So I have a nice strain versus stress here. Okay, so let's plot it then. Okay, I'll plot them. I'll select both of them. Then I'll come here, scatter with smooth lines, and then when I plot them, I'll have such a thing. I need to go to the layouts, then axis title for horizontal. I'll say uh, we have strain here, which the units of it is actually millimeter over millimeter. It doesn't have any unit. Okay, and then axis title for the vertical axis, I will have stress, which is actually in megapascal. Okay, So that's it. That's it. Uh, let's work with this data a little bit. Okay. So from here you can see that this tail is probably not good. So let's say that a rupture is happening somewhere here. Okay. So we manually get rid of the data over here. How we can do that? We can actually do it very good, very easy. You'll see that this is well, actually you can do it in two ways. Like let's do it in the easy way. Okay, so let's make another plot which we are actually only plotting the stress versus the sample numbers. Okay, so I'll go ahead and I'll do this. Okay, so this is the stress versus the sample numbers. uh, so let's say here this is sample number, and here it is stress for me. Okay, they are two different plots. uh, we use this plot a lot. Okay, so let's say that we wanna get rid of the data after this point. Okay, because it's not good. So when I'm going to that data, the cursor of my mouse is just showing me the respective x and y elements. So if it is x and this is y, the respective x and y elements. So if I want to get rid of this, so the x element is 5617. Okay, it means that the data at the row 5617, let's check it again, 56, let's say 5620. Okay, we want to go to data at this 5620. Okay, and then whatever below 5620 is we're gonna get rid of it. Okay, you want to get rid of it. I did it in the hard way, actually. I just went down there. So let's say I have it here, then I'll press shift and then control and down arrow. It will just select all the data below our rupture, and then I'll delete them manually. Okay, and then I want to go to the first row. I'll hold control and up arrow will go to the first row. Okay, and then when I'm doing this, you see that automatically my plots are updated here. Okay, so you'll see that I have a better, more realistic stress versus strain here, and then this is a stress versus the sample numbers. Okay, so our main goal here is to find actually the Young modulus. Okay, so how can we find the Young modulus? Again, I need to work, actually here I need to do the curve fitting. Okay, again I'll need to go to the samples from this one. Okay, and then select the linear part. We have three loadings and unloading, if you remember here. And then from these three loading and unloading until the linear part, I'm going to select those data and then do the curve fitting for those ones. Okay, so one easy way to do this is that actually, because I cannot see the data here, this is dense. Okay, I can go ahead and then from my layouts, from my axis, I'll go to the primary horizontal axis, and then from here I'll go to the more options. Okay, uh, I'm sorry, more options for horizontal axis. Okay, I think my computer is thinking a little bit. Let's paste this. Let's see what's the problem. Okay, sorry about that. I needed to close Excel and then open it again because it was not working. So I was saying that we want to zoom in a little bit here. Okay, so I'll say I'll go ahead. I'll go to axis and then horizontal axis and then the more options for the x-axis. I'll choose the maximum here to for say 2000. Okay, and then click. I'll have the maximum here. I'll have this section zoomed in. Okay, and then when I click on this data, when I go with the cursor of my mouse here, I would say that so from data row to 263, let's type it here so we are not going to forget it, to data here, say 1200. I need those data. Okay, and the rest of data is not really it's not really what I need. Okay, so uh, let's let's go ahead let's go ahead and let's make this one auto again so it has the maximum values for it so we can see the plots. So what I need to do is that I need to go to the row, let's say P 263, and then from this row to 263 to the row 1200. Okay, I need the data. So I'll say P1200, holding shift enter, it will select all of these data. Still I'm holding shift, another right arrow will select all this data. Okay, I'll copy this data. You see I have data below this box, and I add actually data on top of it. So I will copy this data. I will go ahead here. I'll get rid of these two numbers, and then let's say we have the let's name it as loading unloading data. Okay, and then when I have this, I will copy. Okay, let's go ahead. P 263, and then P 1200 shift, and then here I'll have it here, and then I'll copy and paste the data here, and then I'll have labels for them so I would not forget it. So when I am plotting these two data, these two columns, I'll have such a form. Okay, so can I go ahead and do the curve fitting? Well, of course I can, but how much my answer will be good? Okay, the problem is that this portion is the troublemaker. Okay, let's do the curve fitting. Let's see if it is good for the curve fitting. Okay, just select, right click on your data, add trend line. Okay, then choose here there are a lot of options here for trend line options. Okay, so choose the linear one and then display the equation on the chart. Make sure that you're actually selecting this option. Okay, and then by clicking the OK, it will give you the line the best linear line that can fit to this data. Okay, so actually the slope of this line, as you can see, is this number, which is in megapascal. Okay, so if you drop the first three digits, that would be 129 gigapascal. The Young modulus for steel is definitely not 129 gigapascal. Uh, yeah, gigapascal. So it should be close to 200. So for now, let's get rid of the data in here and then see how it changes. Okay, so let's see that the data here is what, 0.0013 for strain. Okay, let's say let's use the match function here, match, and then 0.0013, and then choosing this column, and let's say exact. Okay, so 217, if you go to 200 t 217, so whatever the data is below this is good for us, whatever the data is above it is not good. So I'll select the data below this. I'll hold shift and then control and then down arrow and then another right arrow when I have control and shift still pressed, and then copy, and then I'll say let's have them here. Let's get rid of this one, and let's name it as filtered data, linear portion, linear portion. Okay, and then when I'm double click on this it just automatically expands here, so I can see whatever I have written. And then right now if I plot these two columns versus each other, so I'll go to insert, scatter, smooth lines, I'll have such a nice linear portion. Okay, such a nice linear portion. I'll I'll right click on this and then I'll add the trend. I'll have a linear, and then let's show the equation. Click, I'll see that I have a nice Young modulus of 200 gigapascal here. Okay, so compare these two plots. That is not good. The Young modulus is 129 gigapascal, which is not really good. This is 200 gigapascal point something, which is not really important for us. Okay, so this is how you find the Young modulus. Do not forget that you need to get rid of this portion. Okay, in the next clip I'm going to explain how you can find the yield stress.